Hey everyone, so today I'm going to talk about Lambda Architecture, what that is and why you care. I'm also going to talk about streaming predictions. Alright, so let's get started. So what the heck is this streaming thing? So it's often the case that we want to deploy our machine learning models to make predictions on data as it happens. So imagine data is occurring, it's streaming, maybe it's a log file, right? And we're streaming that data into our model, and we want to be able to make a prediction in real time as it's happening. Um, Operating on a stream of data as it comes in, it creates some unique challenges. One of those is that we want to be able to um, rebuild our model often, probably on some set schedule, so that we can continue to validate our model, but also reflect the changing world. So as the data changes, we want the model to change with it to continue to make the right predictions. So one example of that could be you create a machine learning model that predicts a price, but price is very much dictated by things like inflation and market forces that could impact the price of not your thing but everything, and you'll want to update your model to reflect that, right? A pricing model that was built in the 1930s probably isn't of much use today. So we would of course want to recreate that, and that's a very broad example, but you get the idea. We want to be able to recreate our models so they stay current and proper. That's tricky, and deploying models that can run really quickly on streaming data, that's not easy either. And the last thing is that this is a bit of system stuff, server administration stuff, if you will, but scalability and fault tolerance. How do you make it so that your stream of data is tolerant to faults in any one system? Well, so those are some of the challenges with streaming. The most common way that we address this is through using this thing called Lambda Architecture. So what Lambda Architecture is it's a generic architecture that lets us handle streams of data and deploy machine learning to them. And so imagine this new data up here is a stream, right? So this is new data, and it's constantly arriving. Here's some new data, here's some new data, here's some new data. As this new data comes in, what we're going to do is we're going to split this data, and we're going to send it two places. We're going to send it to a batch layer and a speed layer. So if you note, this little thing here kind of looks like the stream of data splitting and going in two ways. This sort of looks like a lambda, and that's why it's called Lambda Architecture. Not anything more mathy than that. Okay, so what happens is when this new data is being streamed, we deposit it in the batch layer, and it becomes a part of our master data set. And then we also use it to make a prediction in the speed layer. So what happens is we spool up data over and over and over again in this master data set until we have enough. And then once we do all of our model build here. All right, and so then once we have that model built, we can serialize it. So we save it offline somehow. Maybe we pickle it. Maybe we save it in Spark. There's lots of different ways to save a model, and it depends on the programming language you're using. Okay, so once this is all tested and validated and built, what we do is we take this model and we deploy it over here into the speed layer. And so now, as data is coming in, this deployed machine learning model is making decisions for us. What those decisions do, I'll talk about that in a second. But keep in mind, new data is constantly coming in. Now we're making decisions over here. We're spooling it up over here so that we can build the next iteration of the model. And we just keep repeating that. So now we can build a new model every time we think we need one. Maybe it's every week, maybe it's every night. It doesn't matter. Lastly, we have this idea of a serving layer. And what a serving layer does is it takes whatever decisions the deployed machine learning model is making on the data, and it does something with it. The serving layer really depends on the use case or the application, but so one case could be, let's say we're reading the log of a system. So this is a system web log, and what we're going to do is we're going to predict with this classifier if our web service is going to fail or not. We have a very valuable application. We don't want it to fail. And so we're going to use this model to predict if it's going to fail based on what is coming into the log. Well, so then maybe the serving layer, what it could do is on the action taking service, it could send an alert, let someone know, page someone, maybe just even a dashboard. It doesn't so much matter. The idea is that the serving layer takes some action based on what happens in the speed layer on the stream of data. And so that's how Lambda architecture works. There's actually, if you Google search for Lambda architecture, there's a website devoted to this. I'm giving you just the very basics of it, but the point here is I want you to understand that this way to handle streaming data is definitely well established and well known. So let me talk just a little bit more about the nuts and bolts that go into this, though. Okay, so for streaming, when we do this on a web scale sized platform, so a something worthy of a huge application, there's a lot of ways you could do it. The way that I would do it I would be using Apache Spark, and Apache Spark is the next generation of what you might have experienced already in a Hadoop or big data class as MapReduce. So there's MapReduce, and now there's Apache Spark, and Spark is very much in the process of displacing that traditional MapReduce stuff. I don't think that MapReduce is probably going anywhere, but Spark is a lot easier to work in and deploy your applications in. So if you were going to do something like this, I would recommend Spark. You may also be able to do this in Python if it's not a huge data kind of problem. Okay, Spark gives you this thing called Spark ML, and Spark ML is a machine learning library, a lot like scikit-learn, and it gives you the opportunity to do machine learning things. Also, there's a graph library in Apache Spark that may be useful as well, called GraphX. And so either of those things can cover most of the techniques and things that we had talked about in class. It's a little bit harder to program in Spark. Spark runs on Scala, and Scala is it's a functional programming language that runs inside of the JVM, and it looks a lot like Java. If you're an expert Java programmer, you'll probably love Spark. Otherwise, it may be a little bit of a struggle to get into a functional and statically typed language. Okay, so that's kind of Spark. Spark can read streams too. There's this thing called Spark streaming, and what it can do is it can take action on a stream as it happens. And so you can apply a Spark ML machine learning model to a stream of data. And so you can read syslog streams just by listening to syslog port. You can read streams of data through Flume, and Flume is a Hadoop tool that pulls logs in. It's a log flume, get it? Okay, you can also just bind to a port and accept things on a TCP port. Also, you can sub to Kafka, and subscribing to a Kafka queue is really the way I've seen it done most. In fact, I would say that Kafka and Spark are very often used together. So if you don't know what Kafka is, it's Apache's pub sub message queue. There are other pub sub message queues out there. Debating which is the best is way beyond the scope of this class and my own expertise. But know that you probably could get to a place with a little bit of work that you could use anyone's message service and not just Kafka. I'm sure if you wanted to use RabbitMQ or another competing technology, you certainly could do that as well. And so then to my last point, Lambda architecture is just very generic. It doesn't have to be Spark. Spark is one way to do it. It's a very scalable, good way to do it, but there are probably other ways to do it. All right. One last thing I want to talk about when it comes to handling streams of data. You have another option, and that's an online learner. An online learner is one where every time you get a new observation, you make a decision, and then assume that you're going to get a answer like shortly thereafter, right? And so then what you can do is once you have that answer, you can use that single observation and update the weights of your model. So you're learning on every single observation as it happens. In this case, you don't really need a batch layer, so your learning is all in real time. So imagine you want to predict based on ad impression if someone's going to buy something, and so you make that prediction, and then you see just a few seconds later if they actually bought something or not. So that would be an example of a place where you could use an online learner. Um, you really want to be careful when you're doing online learning because sometimes these models can kind of run away on you. And when I say run away, imagine if you get a bunch of really weird data that happens just because weird things happen on the internet. What that can do is that can swing your weights over. And maybe that's what you want. Maybe you want your model to be smart enough to relearn like that. Maybe you don't. So think about that. Think about what the risks are. That said, if you are interested in this, Vorpal Rabbit is a great online learner. It's one that I've used quite a bit myself, and I'm a big fan of it. You can find that out just in Google. It's in GitHub. Works really well. Another great thing about these online learners is that they are not dependent on memory because you really only need a single observation or a small batch in memory at any one time. So the memory that you require to run these machine learning online learners is fixed, whereas certainly the way we've been doing it, it is not fixed. You can consume all the memory you have on your machine very easily. Okay, so that's just a little bit on Lambda architecture and on streaming. Hopefully you'll find that helpful. Thanks a lot.